Planck-scale black hole. Let's start at the absolute floor. This one is the smallest black hole the laws of physics will ever permit. We're not talking small like a grain of sand, or even small like an atom. It's a scale so extreme that the laws of physics as we know them stop making sense. Its temperature is trillions upon trillions of times hotter than the core of the sun and is hot enough to vaporize everything you've ever loved. But there's no real reason to worry. By the time you blink, approximately 1 trillion Planck black hole lifetimes have already passed. It appears, it exists, and it is gone before the concept of a moment has any meaning at all. Now, you've seen the floor. Everything from here only gets wilder. Quantum black hole, also known as mini black hole, is a theoretical type of black hole that could be smaller than an atom. Decades ago, a small number of physicists raised a question that made headlines. Could the most powerful particle accelerator ever built accidentally create a black hole and end the Earth? For example, the Large Hadron Collider in Switzerland. After years of experiments and analysis, the scientists running the collider were never concerned. That's because any micro black hole produced at those energies would be smaller than a proton and evaporate almost instantly through Hawking radiation. It is the process by which any black hole slowly loses mass by emitting energy and can eventually disappear. But here's the main reason nobody panicked. Every single day, cosmic rays hit Earth's atmosphere with energies far greater than anything the LHC can produce. Nature has been running this experiment billions of times over for billions of years, and Earth is still here, and we are still here. The first two were essentially harmless, but the next one on the list could have been born in the first second of the universe and might still be alive right now. Kugelblitz black hole. In everyday life, movies, and even physics classes, we're usually taught that black holes require matter to form, such as a dead star, crushed gas, or something physically collapsing inward. Most of the time, they're right, but there's a type of black hole that completely throws that assumption out the window. A Kugelblitz is a black hole made entirely from light. The word Kugelblitz is German for ball lightning. Just pure photons, concentrated so intensely that space-time itself collapses around them. The universe doesn't care whether it's matter or energy. If enough of either gets squeezed into a small enough space, a black hole forms anyway. According to Einstein's general relativity, this is completely valid. In theory, if you concentrated enough light in one spot, you could create one. However, our current technology is nowhere near capable of doing that in practice. But the math says it's allowed, and the universe has a habit of doing everything the math allows. You might think mathematics doesn't always describe reality, but many things that were once predicted purely through mathematics decades ago have since been directly observed with modern technology. Time and again, the math has proven remarkably accurate, which brings us to something that may have already happened about 13.8 billion years ago. Primordial black hole. In the first fraction of a second after the Big Bang, the universe was so dense and violently energetic that some regions may have collapsed directly into black holes before any star, planet, or galaxy ever existed. These are primordial black holes, and unlike everything else on this list so far, they didn't need a star to die. They formed from the raw chaos of the early universe. Some of them may be roughly the size of a grain of sand, but they could weigh as much as 1,000,000 skyscrapers. And here's what makes them genuinely unsettling. Some of them could still exist today. They've been drifting silently through the universe for nearly 14 billion years. Take dark matter, for example, the mysterious stuff that makes up most of the universe's mass. Some physicists think primordial black holes might be part of the answer. We just can't see them yet. Stellar mass black hole. A star dozens of times more massive than our sun burns for millions of years. Of course, this isn't burning in the conventional sense. What we're really talking about is nuclear fusion. It fuses hydrogen into helium, helium into carbon, and carbon into progressively heavier elements. Then one day, the fuel runs out and the core collapses in less than a second. But there's no need to worry about anyone there, because it will happen faster than the nervous system can even register pain. The outer layers explode outward in a supernova so bright it can briefly outshine an entire galaxy. What's left behind is a stellar mass black hole, dozens of suns worth of mass compressed into a region smaller than Miami Beach. If you were falling toward one, from the outside you would appear to slow down, freeze at the edge, and slowly fade into darkness. But from your own perspective, you'd cross the boundary feeling nothing unusual at all. You wouldn't feel a thing as you pass the point of no return. That's dramatic enough. But when the thing falling in is an entire star, the situation becomes far more extreme. X-ray binary black hole. The previous one is invisible, and it just sits there in the dark. The situation changes entirely when one drifts too close to another star. The black hole's gravity begins tearing gas from the star's surface, spiraling stream of superheated plasma that heats to millions of degrees and blasts out X-rays powerful enough to be detected across the entire galaxy. In fact, this is how most black holes are depicted in the animations and visualizations you've probably seen online. These systems are called X-ray binaries, and they're basically the universe's most dramatic slow-motion breakup. The most famous ones, V404 Cygni and Cygnus X1, sit several thousand light-years from Earth, where an invisible black hole has been methodically consuming its companion star for thousands of years. We've all known someone who seems to consume everyone else's time and energy. The universe isn't any different. That's happening in our galaxy right now as you watch this. One star is just being eaten, and when it is finally gone, the black hole just keeps drifting. But here's a darker thought. What if one is drifting toward us? Rogue black hole. When a stellar mass black hole is born, the supernova explosion that creates it doesn't always push equally in every direction. Sometimes it kicks harder one way than the other, launching the newborn black hole across the galaxy at millions of kilometers per hour. It has no companion star, so it emits no visible light. These are rogue black holes, and there could be millions of them wandering the Milky Way right now. They're essentially invisible, but we can detect them when one briefly passes in front of a distant star and bends its light through gravitational lensing. In 2022, astronomers confirmed the first direct detection of one, just 5,000 light-years from Earth. It had been drifting silently through space for millions of years without anyone knowing it was there. Most of the time, a rogue black hole stays alone forever, but sometimes two black holes find each other, and what happens next is the most violent thing in the known universe. Binary black hole. A decade ago, the LIGO Observatory detected an extraordinary signal. It came from two black holes merging over 1 billion light-years away. When two black holes become gravitationally locked together, they start spiraling inward. As they orbit, they radiate gravitational waves, ripples traveling outward through the fabric of space-time itself. Over millions of years, those ripples carry away energy, tightening the spiral. In the final moments, the two black holes are orbiting each other hundreds of times per second at more than half the speed of light. And when they finally collide, the energy released in that fraction of a second exceeds the combined light output of every single star in the observable universe. By the time those gravitational waves reached Earth, they moved our detector by less than the width of an atom. We detected one of the most catastrophic events in the history of the universe through a disturbance smaller than anything human eyes can perceive. But as insane as binary black hole mergers are, the objects they create are still relatively small, because there's a whole other category of black holes that makes stellar mass objects look like rounding errors. IMBH. Astronomers had already found stellar black holes, a few dozen times the mass of the Sun, and they had found supermassive black holes at the centers of galaxies, millions or billions of times the mass of the Sun. But there was a suspicious gap in between. Where were the medium-sized ones? Intermediate mass black holes were the missing category. Objects too massive to form from a single collapsing star, yet nowhere near the cosmic giants sitting at galactic centers. They may form inside dense star clusters, where repeated collisions between stars and smaller black holes slowly build something larger over millions of years, like a cosmic snowball rolling downhill. We've only confirmed a handful of candidates so far. They may be the stepping stone towards something far larger, something that controls the fate of entire galaxies. SMBH. Nearly every large galaxy in the observable universe has a supermassive black hole at its center. At the heart of our own Milky Way is Sagittarius A star, a black hole containing 4 million times the mass of our Sun. From Earth, its event horizon would appear no larger than a grain of sand viewed from several kilometers away. Like every other star in the Milky Way, our entire solar system ultimately orbits it. When Earth last completed a full journey around the Milky Way, prehistoric reptiles still ruled the planet. In 2022, scientists captured the first direct image of Sagittarius A star. There was a glowing ring of superheated gas surrounding a perfectly dark center where light ceases to exist. For now, Sagittarius A star looks harmless to us, but when they wake up and start feeding in earnest, the results are visible from the other side of the universe. Quasar black hole. Imagine a supermassive black hole waking up and beginning to feed aggressively. If you feed it enough material, something extraordinary happens. The disk of gas spiraling inward heats to such extreme temperatures that it outshines every single star in its host galaxy combined. Not by a lot, by orders of magnitude. These objects are called quasars, and they are the brightest sustained objects in the observable universe. The most powerful known quasar is consuming the equivalent of an entire sun every single day. Its jets of superheated plasma stretch across millions of light years. As they spin, these jets pulse with such consistent timing that quasars rival the accuracy of the finest natural clocks known to science. Most of them belong to the early universe, when galaxies were younger, denser, and far more chaotic than they are today. But some are still active. They light up their corner of the cosmos like a cosmic searchlight that nothing can turn off. What happens when one of those searchlights is pointed directly at us? Could something like this devastate a planet the way the Death Star does in Star Wars? Blazar black hole. A quasar fires jets of relativistic plasma from both poles. Most of the time, those jets point off somewhere harmless into the void, but occasionally, one of them lines up with Earth. That is a blazar. A blazar's jet travels at nearly the speed of light, leaving virtually no warning beyond the radiation itself. If a jet aimed directly at Earth existed within a few thousand light years of Earth, the radiation would begin stripping our ozone layer almost immediately, exposing the surface to lethal cosmic radiation. There would be no alarm, no evacuation, no heroic spacecraft mission to deflect it. Most known blazars are safely billions of light years away. But even a blazar isn't the most extreme thing on this list, because some black holes have grown so incomprehensibly large that they needed an entirely new category. Ultramassive black hole. At a certain point, even the phrase supermassive stops being useful. Some black holes have accumulated so much mass, more than several billions of times the mass of our sun, that astronomers created a separate classification just for them. The most famous examples are Holmberg 15A and TON 618. If either one replaced our sun, its event horizon would swallow every planet in the solar system and extend billions of kilometers beyond its outer edge. Every world you've ever known would already be deep inside the point of no return. It reshapes the structure of the space around it simply by existing. And yeah, they are confirmed objects. They do exist. But what comes next is theoretical. But as I mentioned earlier, the math behind it is completely solid. The slab. It stands for stupendously large black holes. Believe it or not, physicists named it that on purpose. They are hypothetical objects exceeding 100 trillion times the mass of our sun. Their event horizons could be larger than the observable distances between entire galaxy clusters. If you were somehow positioned on one side of a slab and tried to shine a light toward the other side, that light would travel for longer than the current age of the universe and still not arrive. At that scale, the black hole stops being an object you could ever point to. It starts feeling like part of the large-scale structure of the universe itself. We don't know whether slabs actually exist because we've never found one, but the mathematics of general relativity says they could exist. The universe has a long history of doing everything math allows. Somewhere out there in the vast dark spaces between galaxy clusters, there could be objects so enormous that human intuition doesn't just struggle to grasp them. We can casually talk about objects larger than entire galaxy clusters. And yet, somehow the idea that we might be alone in the universe still feels harder to accept. What do you think? If you liked this video, don't forget to subscribe. I'll see you in the next video.